どうも皆さん、一日一問、英語で数学、仕事です。今日はこの一問をしたいと思います。We are given that p is a positive integer, so p is a natural number. Alpha and beta are solutions to this quadratic equation. Well, we can factor 2x minus alpha times x minus beta, and if we multiply this out, we will get this quadratic. So setting the coefficients equal to each other, we get these two equations. So now we want to show that alpha to the n plus beta to the n is even for all natural numbers n. Whenever we see a claim being made for all n, we should use induction. In this case, we will use what's called strong induction. For the base case, we've already established that alpha plus beta is 2 times p, where p is an integer, so this must hold. Now we assume that alpha to the k plus beta to the k is some even integer for all k strictly less than n. Now we want to show that if we assume this, we can show alpha to the n plus beta to the n is an even integer. Now we consider this product, alpha plus beta times alpha n minus 1 plus beta n minus 1, which by the strong inductive hypothesis is an even integer, since we know that this is an even integer and this is an even integer. Now if we multiply this out, we'll get this expression. And now recall that since alpha times beta is negative 1, we can use one of the factors here to change this into beta to the n minus 2 and this into alpha to the n minus 2, so that we get this expression. Now we know by the inductive hypothesis again that this is another even integer, the sum of two even integers, which of course is an even integer. So this takes care of the first part of the question. Now the second part is to compute this limit, but that's not too bad. We first use the fact that alpha times beta is negative 1, so that negative alpha is 1 over beta. And we also use the fact that alpha to the n plus beta to the n is an even integer from the previous part of the problem, so that we obtain something like this. We can rewrite our limit in terms of the betas instead of the alpha, but this is an even integer, and sine is 2 pi periodic, so actually we want to study this limit. Since alpha is greater than 1, that means that the magnitude of beta has to be less than 1, and so beta to the n will go to 0 as n goes to infinity. So when these go to 0, multiplying the top and bottom by pi, we have the limit is negative pi, where here we use the fact that the limit as x goes to 0 of sine x over x is 1. Thank you very much for watching, and please subscribe to our channel.